I'm talking to you, but my mic is over there. I don't know. Nice. Great start. Is my mic working? Let's double check. Hello, hello. Give me a sec. I'm gonna throw you back into the waiting room. Nice. Great start. Is my mic working? Let's double check. All right. Everything seems to be kosher. Let's try that again. Hello, my name is Mike. Welcome to day 17 of Space News. Very excited to have you here. Let's talk space. So payloadspace.com, spacenews.com, and arstechnica.com are my sources. Let's see. Okay, we have a few new articles. Yesterday there was nothing out by the time I was recording the video. Today we have 3 by Stefan Clark, 1 by Jacek Krakow, and Eric Berger. NASA launches a $1 billion Earth science mission. Trump tried to cancel. Building robots for zero mass space exploration. Rocket report. U.S. military still wants point-to-point. India's big 2024 ambitions. Okay, so we can review any of those 3. They all look quite good. Please, if you have any, if you want me to, if you really want me to check out article A, B, C, let me know in the comments and we will go ahead and do that. Over on Space News, we have an article on Beijing government releases commercial space action plan. That could be interesting. It's more political. Well, maybe not. Maybe it has some technological discussions. We know where they're going to launch from, what sites are important to them, what launch pads they plan on developing. There is an article on L3 Harris demonstrates digital phased array antenna system. We're going to check that out. I don't care. And then the main article is satellite operators join forces to chase direct to smartphone opportunity. So this is a follow-up to something we talked about maybe 10 episodes ago. Oh goodness, yeah, there seems to be a lot of operators that are debuting direct to smartphone technology. Okay, so I'm just gonna keep this L3 Harris article open for now. And then last but maybe not least, payloadspace.com. There's a discussion on the Palantir and Voyager partnership for about AI on Starlab. There's the Starship report. I'll open that. We've come across it a couple of times now. NASA's signal to industry and more challenges facing space. I think that'll be pretty interesting and maybe not super technical. All right, so the articles for today, I'm going to keep it to 4. We will check out this building robots for zero mass space exploration. That sounds awesome, really piques my interest. The L3 Harris demonstrates digital phased array antenna system. The Starship report is a paywall, or at least something that you need to sign up for, so that's a no-go. Gives us one more slot. Let's check out this U.S. military still wants point-to-point India's big 2024 ambitions article. We'll put that 3rd. And lastly, NASA's signal to industry and more challenges facing space. All right, so ultra lightweight building blocks can be assembled by simple robots. Let's have a look at this. There is a NASA-branded 4-wheeled robot. I'm not sure it has an arm. I'm not sure what it is working on at the moment, although it does look like it's building some sort of space shelter. So sending 1 kilogram to Mars will set you back roughly $2.4 million, judging by the cost of the Perseverance mission. For those of you that aren't interested, Perseverance was the latest NASA mission a NASA mission that went to Mars. It was a Perseverance rover whose total objective was to land on the surface of Mars and perform a series of experiments within, I think it was a crater or along a ridge wall on Mars. It also had an onboard helicopter called Ingenuity that had something like 72 sorties before eventually dying out. So apparently, per kilogram, it cost about $2.4 million, but let's be honest, it was a government program. Usually those are less money efficient than what commercial entities can come up with. If you want to pack up supplies and gear for every conceivable contingency, you're going to need a lot of those kilograms. So what if you skipped almost all the weight and only took a do-it-all Swiss Army knife instead? That's what NASA is currently exploring. It's a mixture of robots, algorithms, and highly advanced building materials. So it's the idea that an engineering system can not only replicate, but sustain itself in the environment. So when they're referring to 0 kilograms, they're referring to launching 0 kilograms. Which is rooted in self-replicating machines. This is apparently a concept that John von Neumann conceived in the 1940s. Von Neumann was the German rocket scientist that was, believe he assisted the Nazis. Before I start throwing names around. Von Neumann was part of the Manhattan Project. If I'm not butchering this. Yeah, so von Neumann worked on the Manhattan Project. It's unclear if he ever worked for the Nazis before being brought over. That was a thing that happened kind of post-World War II. The Soviets and the Americans fought over who got the best German rocket scientists, physicians, and just scientists in general. So at the time, he was considered the nation's foremost expert on nuclear weaponry and the leading defense scientist at the Pentagon. So if I look up Nazi, it talks about his Lutheran church, I believe. Okay, let's see if he had any ties to the party. I'm just more curious than anything. It does not seem to be the case, so absolutely ignore what I said. But he was involved in the Manhattan Project. Anywho, so this was his concept for engineering. He was very heavily involved in the U.S. space program. So, being able to build self-replicating machines allows you to use materials that are on the Martian surface to perhaps, fix a problem with one of the machines while it's there, or you can launch, maybe you could just launch parts over onto the Martian surface and then have robots assemble those parts. Could save you on design constraints where you have to have the device pre-assembled and then unpack it after landing on the surface. So in the 1980s, Robert Friedrich Jr. proposed a self-replicating interstellar spacecraft called the von Neumann probe that would visit a nearby star system. It would find resources to build a copy of itself and send this copy to another star system. Very interesting. What are we talking about here? So reprogrammable metamaterials has advanced to the point where we can start to think about things like this. Reprogrammable metamaterials. Wow. So the key problems with the von Neumann probes was that taking elements found in the soil on alien worlds and processing them into actual engineering components was resource intensive and required huge amounts of energy. So if we want to convert, let's say, the dirt outside of your home into titanium, we would need the process to do that, so the know-how, and also immense amounts of energy to execute on that process. So I can understand why that sounds like quite a difficult task and requires the technology to improve to a point where you just need the energy that a solar panel can provide and a battery bank to make this kind of conversion happen. So think how biology, one of the most scalable systems, builds stuff. It does it with building blocks. So we have our amino acids, and those amino acids use them to make proteins, which make 200 different types of cells, and then combines trillions of those cells to make organs as complex as hair, eyes, livers, kidneys, eyeballs, whatever. I guess I already said eyes. So to demo this technology, they built extremely strong 3D structures made with a carbon fiber reinforced polymer called a StetTech-NN, and each block had fastening interfaces on every side that could be used to reversibly attach them to other blocks and form a strong truss structure. Okay, I think we picked up the main point of the article. I don't want to stay on this too long. We're 12 minutes in. So robotic building teams. In the lab experiment, 3 robots used all 256 voxels to assemble a shelter in 4.5 days. So voxels are the standardized reconfigurable building block. A 3x3 truss structure made with these voxels had an average failure load of 900 newtons. Okay. Do we have a picture of these? Like, is this a voxel here? Let's see. There are no photos of this right now. Let's have a look online. Metamaterial. Just try NASA voxel for now. Inch worm-like robot system for future deep space. No photos. Oh, here you go. So robots move and assemble composite building blocks into a structure. So what's going on here? Which end are we looking at? This here? Is this? I wish they would point out exactly what we want to look for. So this looks like a truss. Is this the voxel, that the building block that they are creating? Not super clear. So I keep seeing this same device in all of these articles. So it has it looks like an arm. It doesn't give me inchworm vibes. Okay, let's watch this. Ah. Okay, I'm getting much more inchworm vibes now. So point A connects itself, point B hops over, performs whatever action it needs to, and then point B becomes point A, and then they just keep switching over each other. That's fantastic. Wow. Okay, we're gonna... That's a great video. Okay, so 3 robots used all 256 voxels, which I believe were those cube-like structures or like trusses that we just looked at like 2 tabs ago. The robotic team member was a cargo handler that transported the voxels from a supply area to the right place on the structure under construction. Once there, the cargo robot handed the voxels over to a crane robot that placed them exactly where they needed to be, and then finally a fastening robot moving inside the structure attached each new voxel to the structure. Okay. They also tried models like finite state automata, which is how ants build their colonies. That way we could solve high-level problems like finding something and building an enclosure around it. Let's see if we can get some pictures on how ants build their structures. It's the simplest machine to recognize patterns. It's used to characterize a regular language. For example, whatever that is. Automata theory is the study of abstract machines and automata, as well as computational problems that can be solved using them. Which would close connections to mathematical logic. The word automata comes from Greek. Okay, so the study of abstract machines and automata, as well as computational problems that can be solved using them. Okay, so NASA tried using models like finite state automata, which is how ants build their colonies. I'm having a difficult time linking these ideas. If you have maybe an explanation, please do leave that down below. Towers on the moon. So the towers are needed because the landing site for the Artemis 3, a mission intended to bring human astronauts back to the silver globe, is near the moon's south pole. The sun angle there is low, so to maximize the amount of sunlight, you should put the solar panels as high as possible. Okay. You can't bounce radio waves off the atmosphere because there is no atmosphere, and so you need a line of sight for communication. That's fantastic. So one method to, if you cannot see, your antenna, let's say you're in eclipse, radio eclipse per se, and you're trying to communicate from the ground to some object on the moon, or at least on, well, let's say you're going from the moon to an object on Earth, and this receiver's on the other side of the Earth, away from the moon, called moon, let's say Earth, moon eclipse. You could bounce your radio signals from the transmitter on the moon off of Earth's atmosphere and have it be collected by the receiver on the other side of the Earth. Very cool. But on the moon, you do need line of sight communications, says Chung, so the antennas must be as high as possible. How did we get there? And this is going to be the first application, real-world application for the team that is working on this voxel project. Sorry, so I think one of my improvements that I'm going to make going forwards is I will try not to skip around the article too much. Really what I try to do is pre-read the sentence before explaining it on camera, and then I make a live decision whether or not I think it's worthwhile reading that out or skipping it. But sometimes it comes with its downsides, like we skip enough information that going through the next paragraph makes zero sense. The height of the towers in this location must be over 100 meters to get the job done, and pulling that off with current deployment systems would be very difficult. Okay, 100 meters is, especially with these robots that are using these voxels that will be made of materials that were fabricated on the moon. There are a lot of very challenging steps in that process. So the team is now focused on demonstrating how their building blocks and robots could be used in building communication and solar towers. This might be a financially prudent step if these projects don't prove that they will become useful at some point. Those that control the money may cut off the flow. Their next papers are about exactly that. They're going to come out in March. Fantastic. So we will stay tuned, March 2024, for those articles. We are at 20 minutes already, and I haven't even touched on the 3 other articles. So I also promised that I would look into sun synchronous orbit, something that I have not done. Okay, this is a small article, so we are going to go through this, and then we probably won't make it to the other 2. I hope you're Having a fantastic day so far. Let me grab a small sip of water. All right, L3 Harris demonstrates digital phased array antenna system. So we see a picture of a disk, standard satellite disk with a receiver. There appears to be some standalone structure, standalone building, could be a shed. L3 Harris Technologies announced that the results of a 3-month demonstration of a compact digital beamforming phased array antenna system. So during the demonstration in Alaska, the DPAS, which is the digital beamforming phased array system, handled an average of more than 300 satellite contacts per day, including up to 8 simultaneous contacts. We're back. The technology supports the idea of scaling and supporting multiple missions with common infrastructure. Okay, so government and commercial customers are seeking innovative ground systems to communicate with large satellite constellations in low Earth orbit and with constellations that include spacecraft in different orbital planes. Okay, so you can imagine if this is your Earth and you have a satellite flying around in this direction, that's one plane. Another orbital plane would be if the satellite was flying around, say, like so, and then if you wanted to formalize those planes, you might say that this is angle 0 and that the satellite flying in an orbit along this plane is at an angle of 15 or 20 degrees. So here they talk about supporting spacecraft in different orbital planes. As people go to either proliferated architectures or multi-layer architectures, the DPAS technology will come in handy in terms of being able to connect and communicate with the entire constellation, horizon to horizon, simultaneously. So they have there's another benefit, and it's its ability to find and mitigate radio frequency interference. Okay, that presentation could be pretty interesting. 2 qualifiers, you're welcome. Could be pretty interesting. Not very useful. The NOAA agreement. So L3 Harris conducted the DPAS demonstration under the agreement with the National Oceanic and Atmospheric Administration. NOAA, Satellite and Information Service, is looking for efficient and cost-effective ways to collect data from a growing number of satellites owned by U.S. government agencies. So I think, in short, there are many satellites flying around, and so those satellites will overlap with each other from time to time. And if you want to downlink from those satellites reliably, you need to consider the interference patterns that will exist, and there are ways to get around this. You can use different frequencies. You can use different, you can use different frequencies. You can coordinate the downlinking times based off of where satellite A is going to be, where satellite C is going to be. But if you can just have a receiver system that doesn't care, it's intelligent enough, it has the hardware to absorb signals and differentiate signals from multiple satellites in the same area, great. And also being able to receive signals from not just right above you, but also maybe right above you on an inclination of 80 degrees. So really just peeking over the horizon here. You can't see my hand, so the Earth is a sphere, at least some of us believe that, and the satellite will, as it comes up over the horizon, it will get to a point, let's say 5 degrees over that horizon, where you can start communicating with it. If you have from 85 degrees on one side to 85 degrees on the other to communicate with all of the satellites in that purview, and you have a system that can handle that, you're going to make a lot of money. So L3 Harris is extremely impressed with the demonstration results. They will continue these types of partnerships as NOAA and other customers explore ways to integrate multi-band, multi-mission phased array capabilities into their enterprise. L3 Harris conducted its first demo in 2021 under the Defense Innovation Unit contract, DIU. And that was focused, the DIU program is focused on technology to help the US Space Force improve satellite communications. One of the other big swingers in this space is our satellites that communicate between each other. So if my satellite wants to downlink a bunch of information, it might be faster, and it probably will be faster going forwards 5 years, looking ahead 5-10 years, to just communicate my information with another satellite, which has, like let's say a Starlink, which has a very large network, and then at any given time there will be a Starlink satellite that can downlink to Earth. So my information essentially will just hop around satellites until it finds one that can downlink, and we're talking probably megabytes to gigabytes per second of information. Anywho, thank you so much for sticking around. I love you. We will chat soon, and I hope you have a great day. Bye for now.